Good morning. Who was at my talk yesterday afternoon? Raise your hands, please. Okay, great. So I can repeat a few things without feeling guilty. Who here would consider themselves a data practitioner? Raise your hands. All right. Who here is an engineer or a developer? A friendly audience. I like that. Who here is more of a product manager or business person or designer, anything like that? Okay, great, fantastic. You're going to have a lot of fun, hopefully, about data models. But that's great. It gives me some, how shall I say, some insight to try and tailor and adapt the presentation a little bit. All right. Welcome. And then I find out that the clicker doesn't work, actually. My apologies. And there's a little beep on here, so we're going to do it the old-fashioned way with arrow keys. 85% of data projects fail. That's a statistic I kind of want to start with. Numbers are a bit old. They come from VentureBeat. They are a little bit more about AI projects necessarily than data projects, but the lesson holds. Most data projects in big organizations and small organizations, one way or the other, do not meet the intended targets. And we're going to talk a bit through why that's the case and what we can do, at least on the data modeling side, in order to improve that. It's going to be quite a technical talk, which is why I did a sort of show of hands. Luckily, I think the vast majority of you are technical people. I'll try and sort of explain the concepts as well for people that might not be familiar with data modeling concepts, so that you are all seeing this as useful as possible. My name is Thomas. I am from the Netherlands. This is a nice Dutch flag and a windmill to kind of put the stereotypes on there. It was my first time in Malmö. There's a lot of fun here. I have lived and worked my life in different countries. I grew up in Belgium, in Leuven, the biggest and the longest sort of bar in Europe, as they call it, at the Grand Place over there. I lived in London from 2013 to 2018, where I started in the data science industry at that point when everything was still called data science, whatever data job you had. And then I moved to Amsterdam a few years ago. And in the meantime, when I was in London, I started a company called Tasman. At Tasman, we specialize in helping ambitious, fast-growing companies to set up their data stack, set up the infrastructure, set up the first sets of data models, set up the insights, try to have them make that data into actual realizable business value. Is my voice panning left and right as well, or is that just me that hears that? Okay, I think this is just the interference on stage. We do that by being an interim data team, and that actually has given us quite a bit of experience over the last 6 years with about 60 clients to know what can go wrong in data implementations, and also hopefully to have some idea of how to fix it. So yesterday I gave a talk, which will be on YouTube, I think, as well, about the typical pitfalls of data teams. Today we're just going to focus on one particular thing, which is data modeling, and all the different ways that data modeling can go wrong and how you avoid that from happening. This is us last year in front of some crumbling ruins. We're going to talk about startups and scale-ups and the data there. However, the lessons are going to be applicable to bigger organizations as well, like most of these startups and scale-ups are. Why startups and scale-ups? Well, first of all, it's our core audience, so I feel more, should I say, allowed to talk about what happens in startups and scale-ups than I am talking about what happens in bigger companies. Secondly, for startups and scale-ups, the existentiality or the importance of good data modeling is probably even more critical than it is in bigger companies, because bigger companies have bigger teams. Typically, they have a little bit more resources. They have a bit more, how shall I say, room for error, right? In startups, if you do not have a good data model, or if you are messing up your data stack, there's not that much room for error, and quite quickly it will become quite apparent. So that's why that is the case. Who here would consider themselves working for a startup or scale-up? Raise your hands. All right, and who here works for slightly bigger organizations? Okay, good. Hopefully you will have some lessons to take home with you as well. All right, so the sort of typical roles, and it's worth pointing this out because this has changed a bit over the years, but this is the way that we think of the roles in data. Think of them as 3 components. Data engineering, those are people responsible for pipelines, making sure the data goes from A to B. Analytics engineering, that's a bit of a new role. We like the title analytics engineering. It's people who are responsible for taking raw data and transforming it, modeling it, structuring it so that it's ready for analysis. This is a role that has become popularized by tools like dbt over the last couple of years, for instance. And then the third role is the role of a data analyst, and these are people that grab the structured, properly cleaned, well understood data and turn it into business value and insight. And I'm not going to come back to it, so I'll say it right now. This is a massively underrated role, I think. Right? So if you're ever considering a career in data, data analysis is where the going is at the moment. Come talk to me if you're interested. All right, this talk will kind of focus on the middle section, focus on analytics engineering. For those of you in the data engineering space, you will have some exposure to this. For those of you in the data analysis space, you will definitely have some exposure to what they produce. But this talk hopefully will make you a better analytics engineer, or if you're adjacent to analytics engineering, will hopefully make you a bit more aware of what data modelers are thinking about. And hopefully we'll be able to be a bit complementary to the talks by Bill Inman, for instance, later this morning about the data lakehouse. And the data mesh talks. I think there's a data mesh talk later this morning as well, which I would very much recommend you going to. All right, so what are we going to talk about? What's the meat of this? 3 sort of topics. One is the philosophy of data modeling and what's important. That's quite opinionated, so I'll try to explain myself there a little bit. Secondly, beyond philosophy, what does it actually look like in reality? How does it translate into what you do in your team on a day-to-day basis? And third, because we get asked this quite often, I just want to pause and do some best practices as well, because it serves to explain some of the concepts that I'll go through. Before I start, this is going to be quite a subjective talk about what I think and what we think is the best way to do data modeling in startups in very fast and dynamic environments. It's not the only way. There's multiple different ways to skin the cat, if that's the right expression. All right. So let's start with the philosophy, if you're all ready for that. The big problem with data modeling is that often it's not really a consideration in a lot of data teams. And what happens at that point is that you start to build data models based on the business questions that you're going to get from the business teams. You get a business question around, hey, can we see from last week's app release what our average retention is? So you start building a query for average retention, query your old data, surface it in a little report and go from there. Tomorrow you get a question from, say, the marketing team, what the performance of a marketing campaign is. Build a little query to look at the performance of a marketing campaign, put it in a little report, and there you go. What happens is, well, your house might not be on fire in the first couple of months, but you get this stack of queries that you just start executing on an almost day-to-day basis, and there's no design pattern there, there's no consistency there, there's no structure there. This seems obvious as a sort of scenario to avoid, but trust me, most startups I know, most startups that we see kind of find themselves in this pattern at one point, because it is a very easy way to end up in the data model that doesn't have a design pattern, that has grown over time. And how does that happen? Actually, I should come back to the slide later. How does that happen? How does the sort of data model become such a query-driven environment? It's when you realize that even if you do a bit of a design pattern and you start with a properly well-structured data model that's based on a set of business questions and is built on top of a set of data sources, it only covers those business questions in those data sources. And then when a new product manager joins or when you get a new question, typically what happens is you extend the data model to cover those new questions and to cover those new data sources. And when you do that once or twice, it's fine, and sort of your data model will be able to manage that. But like with every engineering system, like all of you developers will know very well, do this a couple of times and you're going to have a very chaotic, very messy, very difficult to understand and maintain data model system on the back of that. Yet this is how most companies, even if they think they do data modeling well, this is how most startups and data teams that we know do their data modeling. Don't do this. This is the result of that. If you do that for years and years and years, this is the who here uses DBT, by the way? Just a show of hands. All right. So I'm not going to go into detail what DBT is at this point, but this is just a graph representation of a data model. This is a very messy data model with no topology, no structure, no design patterns whatsoever. This has grown over years to be an unmaintainable, very hard to understand mess. Yet these sort of graphs, people go to conferences and are very proud of showing their big data model and saying, look at what we have to maintain in the data team, 85,000 models and so on and so on. And it always makes me cry a little bit inside. So let's avoid this from happening. And how do we avoid this from happening? And what does good look like? Key realization. I didn't quite know what the audience mixture would be, so when I talk about modern data stack here, I'm talking about tools like DBT, I'm talking about a sort of wave of new tools that have come into the market over the last 5 to 6 years that should make this easier. It doesn't, alas. Even things like semantic layers, data mesh, data contracts, they are philosophies that I very much agree with for a variety of different reasons that we won't go into this morning. But the modern data stack and the modern tooling does not solve the problem of data modeling. And this is a shame, because if you go to these conferences, and luckily they happen again properly this year after having a hiatus of a few years, everybody is talking about the tools, everybody is talking about the stack choices, everybody is talking about the amazing infrastructure they built. No one is talking about how to solve the data modeling and how to make it scalable. And as we've established, if you do not have a scalable data model, the problems of that are legion. You're going to have inaccurate data, you're going to have reporting to marketing team that give you different numbers than the reporting to the product teams. You're going to have a very hard time onboarding new members in your data team. And as a data professional, you're going to be quite embarrassed about the sort of state of your data model when you ever have to explain it to the engineering team, because they typically do have coding standards and design patterns and so on and so on. There's a term that sort of describes the problem that this creates. It's called data swamp. It's a bit of a play on for those of you who have heard about data lakes and so on and so on. It's essentially, it becomes a total big mess if you start to deploy all of this infrastructure code without a proper design pattern. So instead, what we want to do is, rather than have a data model that scales organically and that creates this very chaotic, very messy picture, that creates this sort of unmaintainable, unstructured, no separation of concerns state of chaos, we want to borrow a few engineering principles, like we always do in data. Whenever we have a big problem, we just look at, have the engineers figured this out 10 years ago or 20 years ago already? And then we borrow that concept. We do the same thing here. We try to design a data model around as many static targets as we can find. So the key thing to realize here is that even if your data model might change, or even if your business questions might change, the object that you ask those business questions of is the business. And if you are, particularly in a bigger company, but also in a startup, once you've established what's called product market fit, right? Once you are a mobile app company, for instance, and you've got a good subscription model going, that won't really change. The layout, the topology of your business won't really change as long as that core business model doesn't change. And there's not that many businesses who change their core business model from time to time, right? So the realization is that the business, that's a static target. That's a sort of ideal layer of abstraction for your data model. And that means that you can preempt, or at least you can think about every possible question that anyone can ever ask of the business can be phrased in terms of that static target as well, because that's what you're playing to, right? What you then want to do in the data model is, even if the data model is composed of a few different sources, ideally we want to find a way to create the data model as a static target as well, right? So that the data model is less dependent on the data sources that you have, less dependent on the immediate questions that come out of the business, but be kind of a design pattern fully inspired by the static target that the business offers. Are you with me so far? All right, excellent. I see some people nodding. That's fantastic. That means none of you have fallen asleep either, which is fantastic as well. I'm going to talk you through how we do that. It is again a concept borrowed from engineering. It leans heavily on a few principles. We talk about separation of concerns. We talk about static targets. And we talk about a sort of layering of the separation of concerns in your data model as well. This is the moment where I am going to mess up my slides a little bit and go back to this architecture diagram, because I need to explain a little bit where data modeling sits in a typical data stack. Okay, and actually let me simplify this a little bit. This is what a typical data stack looks like these days for most small companies. I think most of you will be familiar with this one way or the other. You've got your data that's generated in different sources, whether that's event data coming from tools like RudderStack or Segment or Snowplow. You've got your third-party data or your server data that you extract from tools like Fivetran or Stitch or Airbyte and so on and so on. You might have custom APIs or backend data syncing over and so on and so on. Typically what you do is you load all of that in your data warehouse, you start modeling it, and then you serve that as a sort of centralized, what we call a source of truth to all of your consuming BI tools or notebooks or even production systems when you want to feed things like conversion likelihood back into your marketing tool, for instance. And data modeling is anything that happens between when the data comes into the data warehouse and when it's ready for consumption at the end of it, right? This is all based in a data warehouse. This is the big change from, say, 10 years ago, 15 years ago, when maybe a lot of you are still working in these systems, when you had a few more distributed systems like Hadoop and so on running in the background. This is why I take the easy way out of talking about startups and scale-ups. I don't need to worry about Hadoop or distributed systems. I can fit everything in a nice cloud relational data warehouse, which makes my life easier, which makes the developer's life easier, and which makes it easier to query and talk about here. So we're talking about SQL here as the main way of interfacing with this data model. All right, cool. So that's where the data model lives. Just very quickly talking about this. This is a complex setup, right? But this is a setup that is now accessible for most startups and scale-ups. Everything ranging from getting your data sources in via different tools, getting event governance in, getting your data storage and transformation properly tested and monitored, running everything in one big data warehouse with different layers in there, and then having different consumption patterns on that, whether that is your ad hoc analysis, your dashboards, and so on and so on. And where, again, 10 years ago, this will be only accessible to rather larger companies because of the cost of the tooling and the complexity of the setup. At this point, the nice thing is we can set this up in a couple of months for any small company, even companies around seed series stage, which is a fantastic luxury to do. All right, so data modeling here, literally at the heart of the modern data stack. And now I need to click through all of the stages here again. All right. These problems, they're not new. All right. As I said earlier, whenever in data we have a problem, we look at engineering to borrow some concepts to solve them. Actually, these problems were solved in data a long time ago. There's a couple of reasons for that. Bill Inman is one of them. He spoke yesterday about the history of data warehouses, and we'll speak later this morning about data lakes and equivalent. Essentially, in the 1970s and 1980s, when databases became common, they started to separate out databases from production systems, and they needed a way to start modeling data in there. And as data at that point was still a sub-discipline of computer science, it still is in many different ways, of course. Of course, there were a lot of pattern developments at that point and proper engineering developments there. So the sort of two main, how shall I say, the two main Bibles for data model builds are these two books, Building the Data Warehouse by Bill Inman and the Data Warehouse Toolkit by Ralph Kimball. And in the data world, the two approaches seem a little bit at odds with each other. We're going to tell you later why that is actually not the case, and the way that we talk about it is by giving Ralph Kimball a slightly different scope from the scope that we give Bill Inman. But the point I want to make here is that there is a way of doing this, there's a way of building data models that most startup or scale-up data teams are not that familiar with, but which we can reintroduce into the community. And all of you joining this talk here will go away knowing a bit more about this history of data modeling as well, and hopefully be able to apply it in your day-to-day jobs. So the two sort of ways of talking about data modeling, I just want to describe that a little bit now, just to make sure that we know what the landscape looks like, and then I will give you the interpretation of how to build that static target, how to make sure that your data model is scalable. There's two ways. There's entity modeling, and there is dimensional modeling / snowflake modeling. Entity modeling looks at objects that are entities in the business. So a user is an entity in the business, is an object in the business. A transaction is an object and entity in the business. A subscription is an object and entity in the business, right? So these are things that you can draw it on paper. They exist in the business. You can describe them. You can talk. I mean, a very good rule is you can talk to a business person in your business, and they will know what you're talking about, all right? They might have a slightly different definition, depending on which business user you ask, but they will know what you're talking about, and that's the key thing here. They have relationships with each other. For instance, a user, you can define a relationship between a user and a subscription. A user can have many subscriptions or can have 0 subscriptions, for instance. And you can define a relationship between a subscription and a transaction. A subscription will probably have a few different transactions that keep the subscription alive. On the other side of the spectrum, you've got the more typical star schema modeling. So who here is familiar with the term star schema? Yes, excellent. So you know star schemas, they're fact tables and dimension tables. The similar sort of model will probably look like this here, where you have a dimension table for your users, you have a dimension table for your subscriptions. Those dimensions mean that these are sources of truth, so to speak, that might have some slowly changing dimensions in there, but are as close to the entities as you can get. And you have fact tables for what is actually happening, facts for subscription, facts for conversion, and fact for transactions that happen over there. Not too dissimilar to entities on first sight, but actually they're quite dissimilar because star schemas in these dimensional tables, they're built straight from raw data and they serve to answer a particular set of business questions. That's the key difference. These three things can answer any business question you ask that have anything to do with users and transactions. These tables just serve to answer whatever you made possible by the data you put in there. If you talk to the business people, you talk about the fact transaction table, they're not going to have any idea what you're talking about. Maybe they will because of the fact that you talk about transaction, but once you go into the depths of your star schema, they will lose focus and insight very quickly. So those are the two different approaches. Where it then takes us in a data warehouse is that this is sort of classic design pattern for a data warehouse. You've got your business applications, your data sources. I'm just using the language that people use in these contexts. You've got your business applications that feed data into a data warehouse. In your data warehouse, it gets modeled, and then you have a set of data marts, for instance, that take care of actually presenting this data back into the business. And the key thing on how to square the sort of different design patterns around data modeling, whether you do entity modeling according to Bill Inman, or whether you do star schema dimensional modeling according to Kimball. I just messed the two names up together, my apologies. Is that actually you do your entity modeling in data warehouse. This is where the sort of magic of these entity objects and these definitions happen, and you do your dimensional modeling in your data marts. And that's what we're going to talk about, and that's a sort of central design pattern that I want you to take with you. What most startup data teams do, and where they go wrong, is they skip the entity part, and they start building these data marts straight away, if you're lucky. It might also be that you get a Looker dashboard, for instance, that is built on top of raw data. I've seen a lot of those, and just like the state of the data stack, it makes me cry a little bit inside from time to time. All right. We're going to talk about the data warehouse here in the philosophy part. So first of all, this entity modeling, how do we actually do it? We call this the domain-aligned data model, and actually it abstracts these key entities of the business. We already talked about it. We talked about, for instance, in this case, this example, I take the example of a company. A company has employees. There is a one or many relationship between companies and employees. So we can actually notate that with a nice Krausfoot notation piece over here. And this you can do for an entire business. What you then get from that is what we call a conceptual data model. I made a big jump here, right? So conceptual data model is a paper exercise, a whiteboard exercise, right? That describes, in this case is a bit of a simplified version, but it describes a business according to the object and entities that the business has. So in this case, it is a simple app that allows people to interact with the app on the website, interact with the customer support team, and allows users to get acquired via digital marketing. So what happens here, and I'm going to see if this laser pointer works. Oh, this is a very sad pointer, I'm afraid. No, that would be nice, but alas, I think someone might have taken a battery from this at one point. This is a core entity over here. This is the app user, right? An app user is acquired via marketing events from your digital marketing campaigns, and then your digital marketing campaigns you can describe with a marketing channel, an ad running in that channel, an ad placement that, for instance, publishes the ad on, say, Facebook, a marketing engagement event, a user clicking on the ad, getting into your website, engaging on the website, being converted or at least registering themselves, and that's what we then sort of call the user here straight away. And then the user, once they exist, they can talk to customer support, file a ticket, and a customer support agent can interact with that ticket. It's a very simple, quite linear flow, but it serves to demonstrate the purpose of a conceptual data model. We haven't touched any code, we haven't looked at any data, yet we've got the blueprint of a data model here on paper straight away, right? That's the conceptual data model. When you do this, when you build this as your whiteboarding exercise, you need to talk to the business. But this has a few key benefits. First of all, as a data team, I'm afraid you have to talk to the business. It's a prerequisite for I think, doing a good job as a data team. Secondly, you're going to force the business to make decisions about, hey, we talk about a user. What is the definition of a user, actually? And you're going to find that maybe not for users, although you'd be surprised, but say for an account, for an app user, here in this case I'm going to use the example, the marketing team might have a very different idea of what the user is from the product team, and the product team might have a very different idea of what the user is from the financial team. The finance team might say, oh, a user is anyone who pays for the app. The marketing team might say, oh, no, a user is anyone who comes into the website because of the beautiful marketing campaigns that we've created. You're going to force those conversations to happen before you build your data models. All right? I see a lot of nodding. Excellent. That's very good. Please do that. It really focuses the mind. It doesn't necessarily mean that you need to align everybody around the same user definition, right? But it might mean that for marketing you say there's a marketing user, and there is a sales user, and there is a customer support user. But you need to have a central set of definitions for these objects and entities. If you don't do that, you're going to still have to do it, but after you've built your entire data model at the moment where you surface a report to the CFO that talks about 15,000 users acquired yesterday and you not having any idea what a user actually is, or another report that talks about 12,000 users rather than 15,000 users and having those differences in there because of the different definitions. So that's step one. Step two is translating this into what we call a logical data model, and now we come into engineering concepts. I think all of you engineers will be familiar with the difference between logical and physical systems. The logical data model, and this is a different data model for the close observers amongst you than what I just showed. This is just to serve the purpose here, for the purpose of illustrating here. The logical data model starts to take these entities you've defined and add attributes to them. And these attributes, they are useful because that's the place where, for instance, here in this case for a seller, you're going to say a seller always has a seller ID, and a seller is always linked to a company name and a company address. And this is also where you're going to say the seller ID is going to be critical, but the company name, address, priority, that might not be critical. Those fields might be null. That's the step where you're going to think through this. This is where the definitions really come into play, because there's no user object here. But if you would have a user object here in the logical data model, that's where you're going to define that the user always has a user ID, right? Which means that the user needs to be registered in your backend probably. And that means that you have a very tight definition of what a user is. Logical data model is then translated eventually into your physical data model. That is then dependent, of course, on what you have available in data warehouse and the limitations of your data warehouse. Why is there a difference there? Luckily, modern data warehouses allow you to build quite complex objects, right? So you can translate your logical model quite easily into a physical model. But sometimes you still want to make sure that you take care of unnesting information in your object identity definitions, or of splitting out a few more things, just make it a bit more realistic. All right. So we're at the state now where we have defined our domain model. We've written it out as a set of objects and entities. We all agree on the definitions of users and conversions and transactions and so on and so on. And we've defined what it's going to look like in a data warehouse. We still haven't populated this with data, because that's what you're going to do now. Now you're going to say, we've got a definition of a data model that describes every single object and entity in our business. And only when you've done that, and when that is in the data warehouse, when you've almost defined those tables, only then are you going to worry about how you're going to populate those tables. So that means that your data model is not built based on the data you have available, it's based on the business and the definitions of the business. Remember that. And then when you have the physical data model, you can then translate it into data marts. And for instance, for those of you who use Looker, you can build a data mart in Looker that then queries the tables of this domain model and starts joining the data sets together, so you can get your Looker explorers built quite neatly and quite nicely. Now, coming back to this sort of centralized stack over here with your data sources going into the different layers of your data warehouse, being modeled over here, and then your data consumption tools consuming the single source of truth. We've talked just about the domain model over here. There's a few additional advantages that we haven't really talked about yet. This is a static target we've now built, right? Because we've built this logical model that doesn't change as long as the business doesn't change, because we've built it independently of the data sources that you have, and you've built it in a way that operates at hopefully the right layer of abstraction. You will have to do some thinking work around, let's maybe not have separate tables per country where we're active, because we might add other countries in the future. We might extend our services to Finland or to Estonia. So you might want to put country of a user as a field or as a key value pair rather than as a separate set of tables. But that's the layer. That's the sort of level of decision making you'll be doing anyway. Because you have a static target, it means you've now insulated everything downstream from this data model. You've insulated that from anything that's upstream. That's the separation of concerns. If you're swapping out Salesforce for HubSpot, or HubSpot for Salesforce, probably more likely, in the old data model world, and particularly in the star schema world, you're going to have to change everything downstream here to take care of the new data that's coming in. In the domain model world, you don't. Because the business is still the same. Even if there's Salesforce with slightly different field names, slightly different column names, all you have to do is change the way the data is loaded into your domain model. And everything else can stay exactly the same. Why is this important? Well, for startups and scale-ups, and I don't know about the bigger companies, but for startups and scale-ups, while the business doesn't change, you're going to find that data sources will change, because you will probably start out with an Excel sheet or Google Sheet as your first CRM. And after 6 months, you're going to hire a head of sales, and he's going to say, well, let's get a proper CRM in straight away, so let's put HubSpot in. And then a year after that, after you raised A series, you might change it actually to Salesforce. So you're going to have a lot of change in these business applications, in these data generating systems. But because the business doesn't change, you can build this layer of abstraction, this static targets, that allows you to build everything on top of that. A bit dry, but hopefully that's the sort of core point that I want to make here. And then if you go back to the sort of model hell, 85,000 models, yay, and what this actually, sorry, what this actually looks like in the domain model world, this is what a good data model architecture looks like. A very thin waste, as we call it. You've got all of your sources. You might have to do a bit of munging and staging and transformation in your data sources. But your central core layer of your data warehouse, the domain layer, is very thin, very nicely documented, very well abstracted. And then you can still build a bunch of what we call presentational models. We'll go into that in a second to make sure the data is a bit, how shall I say, where you do a few joins or where you add things like VAT calculations and so on and so on. But because you got the thin waste, you've insulated everything that's downstream from everything that's upstream over here. Right. Still with me? Excellent. Am I talking fast enough, slow enough? Good. Amazing. Fantastic. So just to repeat the 3 big advantages of designing your models, and please, even if you don't follow this domain layer pattern, please design your data models up front. I'm always surprised I need to tell people this, but it is it is quite critical. First of all, you get a static target. Secondly, the model will scale because you've built it in a way that will keep describing the business as long as the business model doesn't change. 3, you will have had the extra benefit of acting as the company's internal consultants or counselors, depending on the state of your company, and building some consensus around the business logic, making people align on what an actual qualified lead is in the sales funnel, aligning people on what a user is, aligning people on what a lifetime value definition is. All right. The two sort of next points are a little bit shorter. Luckily, reality is not too far off. That's why I could use the nice screenshot examples as well. But I just wanted to take you through the sort of pitfalls that you get here, and particularly in startups and scale-ups. The first one is that, and this is the reason why domain modeling and entity modeling fell out of favor a bit over the last 20, 25 years, I think. It does require you to do quite a bit of thinking work up front, right? Because it does require you to have those conversations, understand the business, talk to business stakeholders. In most startups and scale-ups, they work much faster than what typically is necessary there. And domain modeling, entity modeling is typically associated with more classic waterfall projects where you have 6 months to build a proper data warehouse straight away. The comeback there, and the way that we do it for our clients is, 1, you have to have those discussions up front anyway, because even if it takes you a few days, I can guarantee you it will take you multiple weeks if you don't have those discussions up front, right? So it's a sort of whiteboard before your dashboard philosophy. Secondly, you don't have to. The hard part is not necessarily the business logic definitions, because if you know the business well enough, or if you can work with someone in the business that does know the business well enough, most startups and scale-ups that have this need for speed are quite simple businesses. And doing this paper exercise around developing this logical model, it typically just takes us just a few days at the start of any engagement, and we think that data teams with some training, and I'll go through some resources in a second, will allow you to do the same thing as well. Secondly, it requires you to do systems and business analysis. This is not something that most data teams are equipped for, so they will need support from you, engineers, I think, in helping that. And the nice thing is that in most good engineering teams, there will be a relatively good understanding of the different objects and entities in the business already. Whether you use a monolith stack or a microservice architecture, you will have a good understanding of user objects, transactional objects, financial objects, and so on and so on. So please assist your colleagues in the data team with doing this. And third, you need to get your hands dirty, right? As in, it is going to take some iterations once you start populating the data to get something that's scalable. You're going to figure out, hey, you're going to think I've got a lovely layer of abstraction over here, but still find that it might not be the relevant layer or the exact right layer when the business scales. That's all included in those first couple of days, typically in engagement. It comes with experience, but I mean, there's a substitute for getting your hands dirty. I'm almost out of time, so I'm just going to show you this here. This is what an actual domain model looks like for a simple mobile app. It's not even that much more complex than what we talked about earlier. For I asked the team to give me the most complex domain model we've ever built. That looks like this. Yes, it's complex. It's still understandable. I mean, not for you because you can't read the little text. I made sure of that, but it is still an understandable business logic model here, and it serves again every single question you can ask about the business is answerable with a combination of these entities and objects here. Whether you ask about what was my marketing performance yesterday and can we link it to lifetime value down the line, or whether you ask what's the performance of this A/B test pivoted by country that the subscription was taken in, etc., etc., etc. Everything is answerable with a combination of objects there. If it's not, you haven't completed the domain model yet. So there's a nice check there. All right, separation of concerns. The best practices. So, because not that many of you are DBT users, I'm just gonna be quite quick here, but I'll put this presentation online so you can study this in a bit more detail. But essentially, I would just want to say that if you are tempted to think that DBT or any sort of data modeling tool out there would solve this for you, alas, think again, that's not the case. You need to do design work. There's no substitute for all of that. I just wanted to sort of go through the folder structure that we have. Maybe I'll just do it very high level, where this is actually a demo project, but this is the folder structure we use for all of our data modeling projects, where we've got a nice segmentation between the source staging, the source data staging. So source data is where we get the data in from the source systems. We typically use one database in, say, Snowflake architecture, in the Snowflake warehouse. One database per source generating system, whether it's Fivetran or RudderStack or just a simple loader. We've got staging. Staging cleans the data. Often you're going to have to deduplicate your data sets when they come out from the staging layer. Actually, I just want to show here in DBT you can configure your staging layer as your source layer quite nicely with a few freshness tests and so on that are very useful to make sure that you always have fresh data. Staging prepares the data, deduplicates things, it derives a few features, it cleans up some fields. This is where you want to do things like renaming columns, cleaning up your data, deriving some features, and so on and so on. I'm going to skip over intermediate at the moment. The main layer is where the core of the project lives. This is the sort of model that when we talk about the different objects and entities, they're going to each have their separate table definition in here, and it's going to be populated with the data that you have cleaned up in your staging and intermediate layers. Because we, at that point, are independent of the sources, this is where we do things like relationship tests, integrity tests. This is where we define slowly changing dimensions if they're necessary. For instance, a user, we might actually want to put a field in the user object that tells you whether the user is a subscriber or not, but that is typically slowly changing dimension in the language, and therefore you need to model that quite carefully. This is where we keep as much business logic as possible as well. And then, this is what it looks like in DBT with tests. The presentation layer is then taking that and just getting it ready for joining. And this is where you can use your dimensional tables. This is where you can use fact tables. This is where you can use any modeling flavor you want because you've done all the hard work already. Do whatever it takes to sort of get your reporting out. Remember that the domain layer, that's a single source of truth. My friend Joe Rees calls this mixed martial arts modeling, which is the sort of mixing your modeling technologies in the way that makes most sense. All right. Philosophy, what does it look like in reality, best practices. Key summary here, static targets and entity modeling. Separate your concerns, make sure you align the business around it, and don't hesitate to mix your design patterns, whatever it takes, as long as you have this sort of core layer here. Some extra resources. We've recently rebuilt our blog, and there's a few posts on there that go into much more detail about data modeling, so have a look at that. Friends of mine at Reconfigured, it's a Finnish company, they exist purely to make people build better data models, so they're quite passionate about this. They're very good speakers as well, by the way. Go to reconfigured.io, they have a very nice set of resources around data modeling techniques. They've built a beautiful white paper, which they call a manifesto, which I quite like, about semantic modeling, which is data modeling and everything I talked about over here. And don't forget about the classics either. These 2 books that I mentioned earlier, these are good reads. They're in their sort of 4th, 2nd, 3rd editions and so on and so on. These books were written in the early 90s or middle 90s. They are still extremely relevant. And because everything is happening in relational data warehouses these days, I would even say that they're more relevant than ever. All right, everybody. Thank you so much for your attention. Let's get some. Do we have time for questions still? Do we have time for questions, Hugo? We have time for 2 questions. All right, who wants? Yeah.
Maybe focusing more on the startups. Startups, it might not be very static as itself.
Yeah.
It might not be very static on the chart.
Mm-hmm.
Like, do you see situations where it's looking for a building service?
Oh yeah.
Because scale up.
Yeah. Very, very quick. So startups doesn't scale. So sometimes startups just don't have it really figured out yet what they sell, might change pricing models and so on and so on. Don't do this if you don't have product market fit. If you're still changing the pricing models, you're not at the point yet where you actually need a centralized data stack. Just use Amplitude. It's Google Analytics, Amplitude are your friend at that point. Right? Cool. Second question, last question. Steph, yes? We do. Yeah. Yes. Yeah. So we talk about DBT, we talk about documentation, we talk about centralized abstractions. Do we document those, and how do we document it? So yes, we document them heavily. The domain model is a document on its own that has a huge amount of typical descriptive text around it. We save it in Notion for most of our clients. That's the key thing that needs to be documented very well. Presentational models and everything that's downstream, they typically are a little bit more self-describing, and because they serve particular use cases and you've taken away most of the actual complex logic because that's in the domain model, you don't really need to document those as much as you need to document the domain model. But the domain architecture needs to be documented very well. Don't forget about that. DBT can do some of the documentation, but there's no substitute for a properly written set of paragraphs and bullet points in Notion for that. All right, everybody, thank you so much for coming. Have a lovely time here in Malmö. See you later.